Assalamualaikum. We are from tutorial section L0T1 and our group have chosen to do a case study on Bernoulli's theorem. So from our group, myself, Muhammad Rashdan and my other group mates which are Muhammad Haiqal, Shafiq and Muhammad Hadif. So without further ado, we shall proceed with the presentation.
Okay, for the objective, we able to explain thoroughly about the principle and laws of Bernoulli's theorem and to understand and portray the theorem in application in the industry field.
For the summary, Bernoulli's concept refers a fluid pressure to its elevation and speed in water, air, or any fluid with a very low viscosity. Bernoulli equation can be used to calculate these parameters. Students learn about the relationships between the components of the Bernoulli equation through real-life engineering example and usually fixed in the related operation. Okay, for the introduction, Bernoulli's principle: when area available for the fluid to flow decrease, then flow velocity of the fluid increase. This principle was named after the Daniel Bernoulli who first writes in the principle in book named Hydrodynamics. The theorem states in effect that the whole mechanical energy of a moving fluid will contain the energy associated with fluid pressure.
Okay, for the theory, according to Bernoulli's law, if a non-viscous fluid flows through a pipe with changing cross-section, the pressure is lower at constriction where the velocity is higher and greater when the pipe expands out and the fluid stagnates. Okay, as you can see, here is the formula for Bernoulli's law. P is for static pressure, rho is for density, g is for gravity, v is for velocity, z is for elevation height, h is total stagnation height. For Bernoulli equation, we can determine and find that the density is constant, which also means the fluid is incompressible. No heat is transferred to or from the fluid. No change occurs in the internal energy. The equation relates the state at the 2 points along a single streamline.
Okay, we proceed to the process of application. For the air travel is one of the most common everyday implementation of Bernoulli's principle. Bernoulli's principle is most effective in air flight because of the architecture of the plane's wings. So the top of an aeroplane wings is slightly curved, whereas the bottom of the wing is completely flat. So the air passes across both the top and bottom of the sky at the same time. So low velocity produce high pressure, whereas fast velocity produce low pressure. This difference in pressure will generate enough lifting force to raise an object. Also, we can apply this air travel application to the application of the blow the paper. So for the first step, we horizontally under the lips place a piece of paper and blow the air on the papers to the top of the surface with vinegar, and the paper was moving upwards. This is because the air velocity on the top surface of the paper is higher than the bottom surface when it is blown. Bernoulli principle states that when a fluid's velocity is high, its pressure decreases. Due to low air velocity, the bottom of the paper is subjected to considerable pressure. The outcome of this pressure differential is a force that raises the paper upward. So we can relate the application of blow the paper to the wing of air travel that use Bernoulli application.
Okay, last but not least, as a conclusion, from what we have studied and researched about Bernoulli's theorem, we can conclude that Bernoulli's principle and equation are valid for flow as it obeys the equation. As the area decreases at a section, velocity increases and the pressure decreases. And this theory is proven clearly by examples given to further portray the theory. So that is all from us. Thank you for watching. Assalamualaikum.
Waalaikumsalam.